Most students find it difficult to find the resultant of coplanar vectors. Well, the best method in solving this is the method of resolution. But the question is why? You see, when you have more than 2 vectors, then at least from 3 vectors, 4 vectors upward, the best method to use to find resultant is method of resolution. And that's because these vectors are coplanars. Now, coplanar in the sense that they lie between the same axes. This vector f1 lies between x and y axis, f2 lies between x and y axis, f3 lies between x and y axis. The same with f4. Because they lie between x and y, no one lies between x and z or y and z. Though you can't see z here because this is just a 2-dimensional question, x and y. And we're not going to 3 dimensions, but coplanar vector means vectors that lie in the same plane. Now, to solve this, you need to understand the method of resolution, which we've already introduced. But another thing is that there are some things I'm going to say here which I have not said before. That's why I am with this. I'm not here to actually flog anybody, but pay close attention so that you can get every of the nitty-gritty here. Now, pay attention. We have vectors. What you just need to do is draw lines like this and draw that line here. Here, you call this your forces. You say this horizontal component, which by now you must have understood what horizontal component means. This is a vertical component. So let's take every force one after the other now. Let's say we have F1. How do we resolve this F1 horizontally and vertically? Now this is the F1. If you must resolve it horizontally, you are going towards where the angle lies. You're going to say, you're going to use the cos theta. So it's going to be F1 cos theta 1. F1 cos theta 1. But please take note that, you see, if you resolve this F1 horizontally, it's going to be pointing towards this direction. So it's pointing towards the positive x direction. In your graph, you have this to be your positive x-axis, and this is a negative x-axis. This is a positive y and negative y. And so because of that, it's pointing towards the positive x-axis. You see the arrow edge will be pointing forward like this, and that's why it is positive. This F1, likewise, if you resolve it vertically, it will be pointing upward. But I'll be using sine to resolve it because I'm resolving towards where the angle does not lie. We said this earlier. So this is going to be F1 sine theta 1. Now let's go to our F2 now. For our F2, this is our F2. If you are resolving horizontally, you are resolving towards where the angle lies. You are resolving to the axis where the angle lies. You have to use cos as well. So that's going to be F2 cos theta 2. Now, this is going to be negative y. When you resolve this vector F2 will be pointing in this direction. The arrow head is going like this. Anything going like this is pointing towards the negative x-axis. So it's going to be negative. Now, if you resolve F2 to the vertical, what is it going to be? It's going to be F2 sine theta 2. F2 sine theta 2. Now, let's take our F3 now. This is the F3. Let's resolve this F3 horizontally. If I resolve it to the horizontal, it's going to be negative likewise. F3. But is it going to be sine or cos? Well, I'm resolving it to the axis where the angle does not lie. So it's going to be sine. That's minus F3 sine theta 3. Now let's resolve it to the vertical. This is the vector. If we resolve it to the vertical, it's going to be pointing downward. Downward. That's also negative because this is negative y axis. So it's going to be minus F3. But this time around, cos theta 3. Why? Because I'm resolving it to the axis where the angle lies. Now lastly, let's take F4. If I'm resolving F4 to the horizontal, what is it going to be? It's going to be F4 cos theta 4. So F4 is F4 cos theta 4 because the angle lies towards the horizontal and I'm resolving to the horizontal. Now if you resolve to the vertical, what is it going to be? Negative F4 sine theta 4. So let's say this again. If you are resolving to where the angle lies, you are using cos. And you are resolving to where the angle does not lie, you are using sine. I have this principle. I stated this principle and I called it my principle because it makes solving very, very easy when you talk about resolution. But there's something else I want to show here. Let's add another force. Let's say I have another force here, which is F5. F5. Now, there's something you need to take note of here. This force lies towards the horizontal. And because it is in the horizontal already, it does not need to be resolved. F5 lies in the horizontal. So if I want to do that here now, I'm going to say F5. It's just going to be F5. I'm not using cos, I'm not using sine, just F5. That's because it lies in the horizontal already. So it has resolved itself horizontally already. You don't have to resolve it to the vertical. And that tells you that an horizontal vector contributes nothing towards the vertical. If you resolve this F5 to the vertical, it's going to just be 0. Because it lies in the horizontal, it's not going to contribute anything to the vertical. Now let's say we have another vector here, which I call F6. F6. Now, this vector is already in the vertical, F6. Now, it is not going to contribute anything to the horizontal. So, along the horizontal is contributing nothing, that's 0. But towards this vertical, it's going to be F6. But mind you, negative, because it's pointing downward. But take note, it's going to have only vertical component. Meaning that a vector that is already in the vertical contributes nothing to the horizontal. And it's going to have that same value for the vertical. Because it's going to contribute purely in the vertical. So take note of that, on and on. So some authors sometimes uses cos or sine. And I'm going to explain what they try to do. Now pay attention now. Imagine I have a vector here, vector t, that make an angle of 30 degrees, for instance, to the horizontal. You see, if I'm going to resolve this vector towards the horizontal, what's it going to be? It's going to be t cos 30. That's the horizontal component of this t. Let's say I reduce this further and make it 15 degrees now. Same t. I'm looking for the tx now. Horizontal component. What's it going to be in this case? 15 degrees. This is going to be t cos 15. Because I'm resolving this thing to the horizontal. So it's going to be cos. Let me just add the vertical as is. Let's say I reduce this thing further to, let's say, 5 degrees. And you want to resolve this. 5 degrees. Obviously, you agree with now tx is going to be t cos 5 degrees. Now, what if this vector completely lies in the horizontal? What angle do you think it makes with the horizontal? You see the angle keep decreasing until, at this point in time, you say it make an angle of 0 degree to the horizontal. And you notice that if you look for the tx here, it's going to be t cos 0 degree. Why? Because it makes no angle to the horizontal. It makes an angle of 0 to the horizontal. And if you want to resolve this vector to the vertical, to look for the ty, it's going to be t sine 0. Obviously, you know, if you use cos 0 for the horizontal, then vertical should be t sine 0. And that's what some authors do here. When they want to do this F5, for instance, they tell you that it makes an angle of 0 degree to the horizontal. And in that case, if you want to resolve it, they will say it's going to be, for this F5, it's going to be F5 cos 0 degree. Because that's the angle it makes with the horizontal. And towards the vertical, it's going to be F5 sine 0. Now the gist is this. That sine 0 is 0. So whatever F5 is, if F5 is 100, 100 times sine 0, which is 0, will make everything here 0, which is the same value we have here. And if you want to take cos 0 simply means 1. So it's going to be F5 times 1, which gives us our F5 as well. Now look at this now. This F6. What angle does this F6 make with the horizontal? This is the horizontal. What angle did it make with the horizontal? It make an angle of 90 degrees to the horizontal because the F6 is like this, and this is the horizontal. So the angle here and here is 90 degrees. And if you want to use that, you agree with me that resolving to the horizontal is going to be t cos 90. Since this already make 90 degrees to the horizontal, resolving towards that angle will be t cos 90. And so if you do that for F6 from this F6, towards the horizontal is going to be, that's to look for fx of this F6. What will it be? It's going to be F6 cos 90. And if you take cos 90 is 0. So 0. If you say F6 times 0, this will give you 0. Now, if you resolve it towards the vertical, obviously you should be saying Fy, which is F6 sine 90. And sine 90 is 1. F6 and 90 will give you F6. And that's exactly what we got here. 0 for fx and minus F6 for the vertical component, but we're adding negative because it's pointing downwards. I'll put my negative here. So that's exactly what we do. So don't be confused when they use cos or sine here. But I don't bother myself using cos or sine to resolve this. And that's simply because if a vector is in the horizontal, it's just going to have that same value for horizontal, and it will contribute nothing to the vertical, absolutely zero. And if it's in the vertical, it's going to complete. It's going to only contribute towards the vertical and zero for the horizontal. Just make that what you want to do. It makes it very, very easy and not complicated. Now, after you've done this, we're not done yet because you are supposed to find resultant. What then do? You just have to say sum of horizontal component, meaning sum everything here together. If you sum everything here together, whatever it gives to you, that's the sum of f of x. Now, sum up all the vertical together. Whatever it gives to you is the sum of f of y. And you note that down. Your resultant is simply your sum of f of x all squared plus sum of f of y all squared all into square root. That's your resultant. And you can be asked to get angle of your resultant. To do that also, your angle of resultant theta is tan inverse or sum of f of y over sum of f of x. So that's that about this. Angle of resultant is simply the angle the resultant make with the horizontal. So that's that for resolution of coplanar vectors. So let's take this example. Calculate the resultant of 5 coplanar forces shown below. To solve this question, again, we follow the same principle. Join our forces first and writing horizontal and vertical components here. Our forces, horizontal component, vertical component. Okay, so the first force we have here, let's start with this 10. Now, mind you, this 10 is already in the horizontal. So that's going to be, it's going to contribute only to the horizontal. And in the vertical, it will be 0. Now, for some authors, they will simply say it make an angle of 0 degree to the horizontal. And because of that, they will say 10 cos 0. And in that case, 10 cos 0 will still give you 10. So there's no need for that. Let's go get next to the 12. For the 12, this is going to be 12 cos 50. Because I'm resolving, sorry for that. I'm resolving towards the horizontal. And since I'm resolving towards the angle, it's going to be cos. So 12 cos 50 is going to give us 7.71 Newton. Now let's resolve it to the vertical. That will be 12 sine 50. If we do this, we're going to have 9.92. Sorry, 9.2 Newton. Now let's go again. For the next one, the 20 Newton force. Now please don't forget this now. That be sensitive towards when we should have negative or positive. So be sensitive. If I resolve this 20 now horizontally, it's going to be pointing towards the negative x-axis. And now it's going to be negative. Minus 20. Then cos 40 degree. And if we do this, we would have minus 15.32 Newton. Now, if I resolve this to the vertical, what's it going to be? It's going to be 20 sine 40. And this is going to give us 12.86 Newton. Let's take the next one. The 16 Newton force is already a vertical force, so it shouldn't be resolved. It will contribute nothing to the horizontal. Contribute 16, but negative 16 to the vertical. And lastly, we have the 10 Newton, the 15 Newton force. Resolving this to the horizontal is going to be 15 sine 30 degree, and that's 7.5 Newton. And resolving it to the horizontal is going to be 15 minus 15 cos 30 degree. That's because resolving to the vertical, you're pointing downward. And that will give us minus 12.99. And so from here, we sum up our horizontal components. If we do this, we are going to have 9.89 Newton. And for our vertical component, sum of f of y, we are going to have minus 6.95 Newton. So this is what we have. Now, to get our resultant, we are simply going to say sum of f of x squared plus sum of f of y squared all into square root. So this is going to give us 9.89 squared plus minus 6.95 squared all into square root. So our final answer would be 12.09 Newton. That's the resultant. We're not asked to get the angle of resultant, but if we want to do that, theta will just simply tan inverse of sum of f of y over sum of f of x. It's going to be tan inverse of f of y is 6.95. Forget about the negative over 9.89. And then this is going to give us 35.1 degree. Now, I will then need to show my resultant. You know, on our graph, this is like this, and this like this. Obviously, our x is positive, so it lies here. So this is where the force is 9.89. Now, our vertical lies in the negative, so you're not going to draw it here, but here, it's negative. You draw it towards the negative y-axis. You know, this is for y and this is for x. That's why I put my x here. If my x was negative, I would have used this. So, but I'm using positive because it was positive. And this is 6.95. Forget about the negative. Where it is pointing to tells you it is negative. And this is now your resultant. And this is that angle you got, 35.1. So that's how to solve this. You have to just delete this and delete this. So this is how to do it.